Hey there, in this video we're going to go over inverse trig functions, which is going to be invert or arcsine, arccosine, and arctangent. So I'll just do a few examples. Let's say that we have, or first off, one thing that we need to know, see we have sine, and then let's do function. We have sine, cosine, and tangent. In the inverse operations, not operation, let's just say inverse functions. Of these are going to be arcsine x, arccosine x, and arctangent x. And then these can also be rewritten as sine, inverse cosine, and then inverse tangent. All right, now that we have that out of the way, we can go ahead and start looking at a few basic concepts. Whenever, let's say, um, or let's do this first, and this will apply for everything. Sine is going to be sine theta is equal to a. The inverse is going to be sine inverse sine a, our product, or the value that we get from it, from this, is equal to theta. So a real quick example would be inverse sine of 1 is going to equal pi over 2. How do I know this? I just need to know what makes 1 from sine. So sine of pi over 2 is going to equal 1. And then one more thing, um, anything for sine between, it is going to be between negative pi over 2 and pi over 2. If you put, oops, if you put this function, if you put this function into your calculator, you will see that it only goes from negative pi over 2 to pi over 2. Let's do one with cosine. An easy example for cosine would be, say, inverse of cosine is root 2 over 2. What makes root 2 over 2 from cosine? That's just going to be pi over 4. If you look at your unit circle, you will see that it is pi over 4 makes root 2 over 2. Now, if it was negative, you would probably have 3 pi over 4, since that is going into the second quadrant, and that is when cosine is negative. Cosine, the range for cosine is going to be pi to whoops, 0 pi. And this is the upper half of the unit circle. Let's go ahead and do one more for, let's say, tangent. Let's do inverse tangent of negative root 3. So what makes negative root 3? Well, if we look at our unit circle, cosine is positive here. All of them are positive in here. Sine is positive in here, and tangent is positive in here. However, tangent, its domain, is going to be from um, negative pi over 2 to pi over 2. Or this can be rewritten as this can be rewritten as this. So now that we know that, we know that's going to be somewhere within here. Now, it can't be in the first quadrant because all of them are positive. Cosine, sine, and tangent are all positive in the first quadrant. So that means our answer is going to be somewhere around here. Now, first of all, what does x need to be to equal negative root 3? X really, or if you look at your unit circle, um, and we look down here, anything that is, um, let's see, hmm, anything that is really pi over 6, we'll do n pi over 6, in that is not in the first or third quadrant is going to be negative. So what down here is n pi over 6? That makes negative root 3. That is going to be 11 pi over 6 because it's almost to a full 2 pi, but not quite. However, our domain restriction is negative pi over 2 to pi over 2, meaning that we'll have to take something negative. Also, this is not 6, it is 3. My bad. So n pi over 3, 11 pi over 3. It's not within our domain. What does that mean? Well, that means we need to start going backwards into cosine. So we just take what I generally like to do since this is 11 pi over 3, another coterminal angle for this. X would just have to equal, let's see, negative pi over 3. And that's really it. Now something a little bit more complicated. Um, are when it is an inverse and then a regular trig function. Let's take, for example, um, cosine or inverse cosine sine 7 pi over 6. Now, what is this equal to? Well, we don't know yet. What is sine 7 pi over 6? Well, I know that it is past pi, so it's going to be in the third quadrant, meaning it's going to be negative. So we're going to have cosine, inverse cosine of negative something. Now what is pi over 6? Um, pi over 6 can be translated to 30 degrees, if that's easier to think in. Sine of 30 degrees is just going to equal 1/2. What do we need to, or now, if we want this to be negative, what angle do we need cosine to be to get this? Well, again, if we look at our unit circle, C, A, S, T, and if you remember, our range for cosine is going to be from 0 equal to the inverse of cosine. That was awful. Pi. Again, or that is going to be everything up here. Again, we cannot have it in this first quadrant because it is going to be positive. We need it to be negative. So what does that mean? We need to have it past this point. We need to have it past pi over 2. So what makes 1 over 2? Well, anything that is pi over 3. Wait. Yes, pi over 3. So cosine, or the inverse cosine. Actually, let me write this out first. What does x need to be to equal um, negative 1 over 2? And or it has to be between 0 and pi. So we know that it's in the sine area, has to be past pi over 2. So we're going to get something over pi over 3. Um, but since pi over 3 is in this area right here, and it's not quite pi, it's going to be 2 pi over 3. So this is just going to equal 2 pi over 3. I'll go ahead and do another example. Let's do tangent inverse cosine 1 over 2. We'll take this out first, so we don't, or so just ignore the tangent there. What does cosine need to be, or what does x need to be to equal 1 over 2? We went over this before. It is going to equal, or x is going to equal pi over 3. And since it's positive, it is just going to be in that top right, where it's going to be in the first quadrant where all of them are positive. And because of our domain restriction, it has to be in the first quadrant. So now we have tangent of pi over 3. What is tangent of pi over 3? Well, this is roughly 60 degrees. Tangent of 60 degrees is going to equal root 3. And there we go. That is our answer. That is all I really have for inverse functions. Actually, one more thing. Whenever we have, go ahead and create a new one. Whenever we have, let's say, sine, inverse sine of, let's say, root 3 over 2, these signs are going to cancel out. Because if you do it, you're just going to take the inverse, or you're taking inverse of 3 over 2. Inverse sine 3 over 2 is going to be pi over 3, and then the sine of pi over 3 is just going to equal root 3 over 2. You're just going to get the same thing. That's going to equal root 3 over 2. Same thing with cosine. Oops. Actually, let me do this. Same thing if you have it on the outside. If you have it on the outside, those are going to cross out, and you get root 2 over 2. That's all I really have for this. And yeah, see you later.